Hello guys, welcome once more to another live video on our YouTube channel. So we are going to be looking at further maths, further integration, reduction formula. So we have an integral in terms of n, which is the integral from -1 to 1, the integral from -1 to 1 of 1 plus x to the power n times the square root of 1 minus x for all n greater or equal to 0. We have to show that 2n plus 3 times in is equal to 4n times in minus 1 for all n greater or equal to 1. Okay, so basically we are going to be using integration by parts, okay, to perform the gymnastic here. Now when I see my integral, I see in minus 1. It therefore means that if I find in minus 1 originally, the power of n will just decrease by 1. It will be the same thing, but just that in a place of n, I replace n with n minus 1. And for me to have something in terms of 1 plus x to the n minus 1, it means I've actually differentiated 1 plus x to the n. So that helps me to do my substitution. So we are going to let u to be equal to, 1 plus x raised to the power n. Then we differentiate both sides. So du is going to give us, now to differentiate 1 plus x to the power n, we drop the power, which is n, then we differentiate the 1 plus x, we just have 1, okay, then we multiply the result with 1 plus x raised to the power n minus 1, then the x, okay. So I'm just going to rewrite everything as n times 1 plus x to the n minus 1 dx. Then again, we are going to let dv to be equal to the square root of 1 minus x dx, because dv is the remaining part of the integral of the integrand, which is this remaining part, the square root of 1 minus x times dx. Then we are going to integrate both sides, okay. So it means that v will be equal to, now let me give a basic recall before I come and get v. So if I ask you to integrate ax plus b raised to the power n dx, what do you do? So what you do is that in the denominator you differentiate ax plus b to have a, then you multiply it with n plus 1, and in the numerator it stays as ax plus b raised to the power n plus 1. Okay, forget about the constant of integration for now. Normally we need to add it, but let's just forget about the constant for now. So when you integrate a linear function raised to a certain power, this is what you do. This does not work for when you have quadratic or whatsoever. It works only for linear functions. So what I'm going to do is that this square root of 1 minus x, okay, we can rewrite it as 1 minus x raised to the power half. Are we there? So you see that your n is half. So here we are just going to have, in the denominator we are going to differentiate 1 minus x to give us -1. Then we multiply it by half plus 1. Then in the numerator we have 1 minus x raised to the power half plus 1. So that's just a basic principle. Okay, so half plus 1 is 3 on 2. So in the numerator we have 1 minus x raised to the power 3 on 2. Then in the denominator we have -3 on 2, because half plus 1 is 3 on 2, but there is a negative sign. So it just gives us -2/3, okay, times 1 minus x raised to the power 3 divided by 2. So that is what we have. Okay, so I think I can remove this recall from here. So it therefore means that what is in? uv minus the integral of v du. That's a formula, but we need to put the bounds. So in will be equal to uv, so just a minute, let me try to take a bracket which I will use. Okay, so uv, what is u? U is 1 plus x to the n. What is v? Because it is uv, this is v, okay, this is my v, so I'll just put the v here, okay. Then our bounds are from 0 to 1, alright, from 0 to 1. Wait, I don't know why everything is supposed to be in 16. I'm just making it large so that it is visible enough. So this is uv, then minus the integral of v du. So we are going to have the integral from 0 to 1 of v du. What is v? V is everything here. So I'll put this minus to that outside. Okay, minus to that outside. Put this minus to that outside. Then I'm going to put this man inside. Okay, put this man inside. So that is v. I'm done with v. Then what is du? This is du. So this du has an n, which I'm going to put outside because it's a constant. Just multiply with 2. Then the remaining part is now everything here. Okay, everything there. But now they say dx. Voila. So let's now go. So this means that in is equal to, let's fit 1. If I fit 1, I'm going to have 0 here. Okay, once I fit 1, I get 0 there. Okay, so if you fit 1, you have 0. A is from negative 1 to 1. Not from, it's from negative 1 to 1, sorry. So if I fit the upper bound, which is 1, I'm going to have 1 minus 1. I don't even need to fit here because this term gives me 1 minus 1, which is 0. So the upper bound gives me 0. Now let's fit the lower bound. If you fit negative 1, you're going to have 2 here and you're going to have 0 here. So you have 0. So everything becomes minus minus is plus. So you just have 2n over 3 times the integral from minus 1 to 1 of everything. Okay, now this is time for simplification. So watch as I simplify. So I have 2n over 3 times. Now let me try to simplify this integral and you see what is going to happen. So what happens is that I'll first of all write, now if I check originally it was a square root of 1 minus x. Okay, so this 1 minus x to the 3 on 2 is just the same as 1 minus x to the power half times 1 minus x to the power 1. When you add the powers, you have 3 on 2. Then this 1 plus x to the n minus 1, we can write it as 1 plus x to the n, then times 1 plus x to the power negative 1. Voila. So what I'm going to do now is that I'm going to pair. So this is still in. Okay, so this is still in. So it means that in is equal to 2n over 3. Now the integral from minus 1 to 1. Now what happens is that I will rewrite this man as a square root. Okay, then I'm also going to write this man also. So I'll first of all pick these two terms and write them first. So I'll pick this term and pick this term and write them first. So I'm going to have 1 plus x to the n times what? The square root of 1 minus x. Then what is left? What is left is 1 minus x times 1 plus x to the negative 1, which is just the same as 1 minus x divided by 1 plus x. Alright, then the x. Remember that this 1 plus x to the negative 1 is 1 over 1 plus x. So when you multiply with this man, we just have this. I'm just trying to rearrange it so that it looks nice. Now let us deal with this portion. Okay, let us try to deal with that portion. So to deal with this portion, we do long division. Okay, but long division is kind of long. So what I'm going to do is that I'm going to create, you can actually do long division. Okay, you can actually do long division, and then you have the quotient, the remainder, and the divisor, and then you come and fit. But it's going to be lengthy since I am typing. So a short way is, okay, since I see a negative sign here, my denominator is 1 plus x. Alright, so I'll just write my denominator. Now in my numerator, I will create my denominator in my numerator. Then I simplify the numerator. Then I add something to this that will give me back 1 minus x. Okay, so to do that, what do? I think for us to have negative x, if we subtract 2x, it gives now. But now it's not really nice. It's not really nice. So what I'll do is, let me just factorize the negative sign from the numerator. I'll be left with x minus 1, then divided by x plus 1. Let me write it this way. Okay, so the negative sign is still outside. I'll still write my x plus 1 here. Up there, I'll write x plus 1. Okay, so I'll first of all write x plus 1. Then what will I do with x plus 1? to still have x, to get x minus 1, I'll subtract 2. Are we there? Voila. So it therefore means that okay, so it means that I can now introduce this negative sign back into it. So if I introduce this, or let's just put a negative sign still outside, then we are going to have x plus 1 over x plus 1. Okay, so we have x plus 1 over x plus 1, then minus 2 over x plus 1. That is what we have. Now this gives us 1, okay, and this just stays like that. If we now introduce this negative sign, I think if you do your long division, your answer is going to be negative 1 plus 2 over x plus 1. So this is going to be your answer. I was just trying to make a shortcut. Okay, so what happens is that I'm going to rewrite, what is this? I'm going to rewrite this. Okay, so in will give us 2n over 3 times, in fact, let me just copy everything and then replace what I have there. So I'm going to replace this man with its identity, which is negative 1 plus that. Okay, that is it. Now I'm going to call everything here a single term. Okay, so everything here is a single term, they are moving together. Alright, so I'm going to multiply it with negative 1, then later I multiply it with everything here. So you see what we are going to have. So it means that in will give me 2n over 3. Now the integral from negative 1 to 1, if I multiply everything here with negative 1, is going to be negative of 1 plus x to the n, the square root of 1 minus x dx. Then plus, I'm separating the integrals, okay, plus 2n over 3 times the integral from negative 1 to 1. If I now multiply everything here with 2 on x plus 1, I'm going to have 1 plus x to the n, the square root of 1 minus x, multiplied by 2 over x plus 1 dx. So I've just separated the integrals. But now this man, yes, anyways, so I've just separated the integrals. Okay, let me try to decrease the size so that it enters on a single line. Okay, increase the size again. So let's now simplify and see. So in is equal to 2n over 3. Now this negative sign goes out, so you have the negative sign outside here. What will be left? We'll be left with the integral from negative 1 to 1 of 1 plus x to the n times the square root of 1 minus x dx. Now plus, now this 2 that is here meets with the 2 outside here to give us 4. So we have 4n over 3, okay, times the integral from minus 1 to 1. Now I'm going to write, you see, this 1 plus x to the n divided by 1, because this x plus 1 is the same as 1 plus x. Okay, so this person here, if I take it to the numerator, it becomes 1 plus x to the negative 1. So this is going to be 1 plus x to the n. I'll just put the 1 plus x to the negative 1 before I put the square root of 1 minus x, then the x. But we know that when we combine these two things, we just have to subtract the powers. Voila. So what do we see from here? We see from here that in is equal to negative 2n over 3. What is this? This is in. That is in. It was given to us originally. So I just replace it with in. Then plus 4n over 3. What is this? In minus 1, because there's just a difference of n minus 1 up there. So we have in minus 1. Voila. So I'll multiply all through by 3 to remove the denominator. So I'm going to have 3in is equal to negative 2n in plus 4n in minus 1. Okay, so therefore I'll add 2n in on both sides. So I'm going to have 3in plus 2n in equal to 4n in minus 1. Then I now factorize in from the left hand side. I'll be left with 3 plus 2n. Then we multiply it with the in equal to 4n times in minus 1. And with that, we have proven. Let's rush and see if that is a proof. So perfectly, we arrived at the perfect conclusion. So guys, thank you for watching. Thank you for staying with me. See you guys in the next live video. If you have a question, the comment section is open for you. If you have a problem, you can get to me on WhatsApp. I'll put my number in the comment section. So I'm going to solve your problem live on YouTube so that other people who have same problem are also going to be benefiting. Okay, see you guys in the next video, and until then, stay blessed.